1, 2. Looks like we're live with some sound. Sound looks like it's 5 by 5. Cool. Hi folks, if you're listening, great to have you here. I'm going to start the lecture in any minute now. I can see 9 folks watching on YouTube. Thank you so much for joining me early on this week 8 Monday morning. And there's one dedicated Comp 1720/6720 student over on Twitch. I wonder if there's folks who are watching this in the team. It's a bit harder for me to check on the viewers for that. Someone's hearing me, that's great. Good to hear. I can hear you too. I can see your I can see what you're saying. I'm just going to make sure I'm logged in on all my stuff, so I'm not having any slowdowns during the lecture. It's good to be able to get myself in a good flow. Someone's there on Twitch. Good morning to you too. The Twitchers, the game fans. Editor.p5.js.org. I'll log in over here as well. Oh, yeah, okay. I don't need that. I can open my game plan. I had a game plan last night. Someone's saying something about Sunday, 3rd October. Is that daylight saving time? Oh, great. Well, I'm just going to, now that we're having, you guys are teaching the class for me, which is great. Just get my little remote controller online. You folks should know that I love to have my little remote controller ready. G'day folks, how are you going out there? Out in computer land. Just going to make sure my recording is recording. Start recording. G'day everybody, welcome to lecture week 8, part A. First lecture for week 8, here in Comp 1720/6720. Thank you so much for joining me live. Everybody who's here online right now, out in the chat. It's always great to have folks joining me live and asking loads of questions in the chat, giving me lots of things to discuss and react to. It's just a lot of fun to have you there in the chat, enjoying this process of art and interaction computing along with me. We are changing tack a little bit this week. I think I've started to introduce this concept that the course moves in a bit of a different direction from this point forward. And week 7 was really the last, I suppose, code topic in the course. The code topic being how to do sound in P5. You all learned how to create some sounds from scratch, and you learned how to load samples or recorded sounds into your P5 sketches. We talked a bit about some of the complications of dealing with sound, why sometimes it doesn't work because your browser doesn't want your tabs to just automatically be playing sound all the time. But the core point of the lecture was about the different ways in which we can create sound with computers. Basically, those two main methods, using generating sounds from scratch with synthesis or playing around with recorded sounds using samples. And we talked about how that relates to art and music and how you can really creatively engage with sound in your sketches. And I hope you're all thinking about that as we get through the third assignment and towards the major project. We are now starting. The lectures tend to work 1 week before the content. And we're now starting to look at things that you will do in your labs. I mean, the lectures are 1 week before the lab content. This is what you will do in your labs next week. This week, you're still working with functions, images, and sounds, just as we've been practicing in the last few weeks. But next week's lab, you'll see, is quite different. And it's the start of our series of 4 labs that are entirely dedicated to developing, framing, reframing, editing, critiquing, engaging, and improving your major project ideas and execution. So you might be starting to feel a bit worried that this major project is a very large part of the assessment. Yes, it is. But we give you a lot of support in order to help you achieve that. And the support we give you are 4 labs dedicated only to developing this idea. And that doesn't mean that you sit there and code. That means that you bring your ideas to the lab, your plans for your major project, and then your sketches, and then your designs, and as it's getting bigger and bigger, you bring that to the lab, and you have a chance to engage with that with your colleagues in the lab, your fellow students, as well as your tutors. And the pre-lab exercises that you will have to do are also all about your major project. So you should feel that your major project is not a task which is insurmountable. It's a mountain you have to climb. You have no idea how to get to it. It's something which we help you to achieve over the coming 4 weeks. Now, what are we doing this week? This week's lecture is called Storyboards. And today's lecture is all about how we can conceptualize an interactive process outside of making it, coding it up and developing it in person. So what we're really thinking, moving myself to being small, if that's ever going to work. Whoops. There we go, I should be small. What I want you to think about is this, and this is important for assignment 3 and for the major project. Do you want to be in a situation where you develop your project, your interactive artwork, and you have no idea how it's going to work until you've done it, and then you just have to see how people react to it? Or do you want to start with a plan for how viewers will interact with it and use that plan to guide your process of creation? Or do you want to do a bit of both, where you have plans, implementations, taking these things in turn? And how are we going to conceptualize that process? Because in your assessments, in your labs so far, we've done a lot of implementations, and I've really encouraged you to do a lot of work in P5, and that's really important. But we haven't thought so much about how you plan an artwork, because the assessments so far, even including this upcoming assignment 3, are designed to be fairly small. They're small projects, small amounts of interaction, small amounts of conceptualization, a small target in terms of what you're supposed to create, name tag, window, an ad. So there's not that much freedom in terms of framing the whole process. So you haven't needed these tools, but you do need them for your major project. Let me just say a few words about what's going on this week. Don't forget, your assignment is due on Tuesday, the 5th of October, 2021 at 9 p.m. I said Australian Eastern Standard Time. I think it might be Australian Eastern Daylight Time. Let's do a bit of research right now. Canberra, daylight saving, 2021. I should have thought of this. Someone just pinged me in the chat and I remembered. Daylight saving starts on Sunday, October 3rd. That means it's a different time zone. I'm going to change it right now and it'll update in the slides. AES, oops. Oh no. AEDT, Australian Eastern Daylight Time, because it will be daylight savings time. There we go. I'm good now. We know what times are. Assignment 3 is due on Tuesday, the 5th of October at 9 p.m. Australian Eastern Daylight Time, which will be 1 hour different. Spring forward, it'll be 1 hour earlier than before. So that means that you need to, if you're outside of Australia, you're not working within our time zone in your everyday life, you need to be especially careful about the times that you are submitting your work. We do look at those deadlines. Sometimes I've had folks who are submitting work after the deadline, and then I've had to have little discussions about them about what has been going on. Really, unless you have, if you need an extension, I think word may have gotten around. If people come to me and ask for an extension, they have a good reason, they get an extension. I don't want to have people handing in work late. I want to have people asking for extensions and then I give them that extension. Of course, if you come to me with an extension because you're busy, well, everyone's busy. That's not a good reason. But if you have medical reason, something that unexpected which has happened, handling lockdown, talk to me about it and we can come to an accommodation, a way that we can let you have the best chance at getting your work done, as well as meeting our expectations in terms of handing in work regularly. So it's best to have a discussion. Don't just hand things in late and expect that something will happen. You might be very disappointed about what happens with it. So another thing to note, that assignment is due on a Tuesday, not a Monday. The reason is that in Canberra, the coming Monday is a public holiday. That means that we don't have assessments due on public holidays. That's a generally accepted view at ANU. Often we don't have assessments due on public holidays. We also don't have a class on Monday. We will have a class on Thursday that week. So what I'm going to do next week is give you one lecture on Thursday, and the Monday lecture will be a recorded lecture from my colleague Tony Curran. So it's not desperately important that we make up that class, but I'll give you a lecture on a topic which Tony is better at talking about than me, and I think that'll be interesting for anyone who wants to take that extra information. Next week's pre-lab is something quite different, because next week's pre-lab is your first starting point for your major project. What you're going to do is create a storyboard for an aspect of your major project. I'm just going to pop onto the lab page to show you what that might contain. Here's the prompt. Oops. Here's your pre-lab task. Create a storyboard of your major project by any method. It could be hand-drawn sketch, Microsoft Paint, Photoshop, Illustrator, or in fact P5. And I do encourage you to make use of P5 in order to help practice that skill. This storyboard should illustrate how you plan to interpret the major project theme. Okay, so there's two things. It should give an impression of what's happening within your major project and make sure that it illustrates your interpretation of the theme. Just reminding you what the theme is. This year's theme, Timeless Attraction. That's your theme. So you can interpret this theme however you wish, but it has to be illustrated within your storyboard in some way so that you can discuss it. You only need to write a little bit of information about this, but you do need to get that storyboard into the course forum so that everyone can see what's happening before your lab next week, because during the lab, you will be talking about that storyboard, your interpretation of the theme. You'll talk about other interpretations of the theme, discuss affordances and interactions, think about coherent artistic visions. I've got lots of tasks for you to start packing in information around that storyboard and making decisions and testing out ideas, but you need to have the storyboard done in order to do that. If you don't know how to make a storyboard, then you're in luck. I've got a lecture coming up in the next hour or so to talk about it. So this is a very important lab. It's the start of your major project work. And I hope that you'll feel by next Tuesday, well, the people on Tuesday labs might have their assignment due that evening. I would encourage you to get your assignment done over the weekend so that you can focus on the storyboard lab and not be thinking about assignment 3. But as I said, we tend to have deadlines only on work days, not on public holidays. Okay, where are we? Back to the lecture content, storyboards. I want to talk about inspiration and iteration. Inspiration and iteration. And I'm talking here about artistic processes, or the process of creating an artwork. And I guess I could say that we've looked at a lot of software engineering for artists so far. Software engineering for artists. Because I've been talking about ways that you can represent artistic concepts within a programming language, within computer code. That's mostly what we've done so far in this course. And what we haven't done so much of is artistic process for software engineers. So I'm specifically writing software engineer here, not coder or not programmer, because I think within software engineering, that's a field which is related to completing projects, specifying projects, completing them on time and on budget, and having assurances about the quality of these projects. So that's software engineering. So what's artistic process for software engineers? And in this lecture, we're going to start thinking about what that could be. I hope this interests the artists out there as well, or folks who are not software engineers. But what's our goal here as an artistic software engineer, a code art engineer? Our goal is to create a compelling and sophisticated interactive artwork. Those are the marking criteria of the major project. You can see those in the FAQ. Often folks will ask me a question on the forums about their feedback. Oh, what's more important, the art or the code? And I say, well, if you look at the marking criteria, you'll see that both are important. So we want to have both something which is compelling artistically and compelling technically. Compelling and sophisticated interactive artwork, that's the goal. So we want to have a high assurance of success. This is where the engineering part comes in, because engineering is not just about having a goal and saying, oh, well, I guess if we meet the goal, then great. And if we don't, better luck next time. No, engineering is about doing it right. When you are doing this, when you're a structural engineer, if you're designing a bridge, you want that bridge to never fall down, right? If every fifth of your bridge falls down, you don't just say, oh, well, better luck next time. You lose your job. You go to jail, probably. But within software, we also have to think about success. And I want everyone in this class to be thinking that their goal is to create a compelling and sophisticated artwork, and to feel confident that they can have success at that through this process we're going to take over the next few weeks. So how are we going to have success? How are we going to have success, and how are we going to make sure it's there? So this comes back to a question, an artistic question: where does inspiration come from? So here's a guy, this artist. He seems like he's ready to paint a picture. He has a canvas in front of him. He's got some old masters in the background, and he looks like he's just had some kind of brain explosion. There's some inspiration rays have entered his brain, and now he's going to be able to send them back out onto the page, and it's just whatever he does is going to be amazing. You just start from a blank piece of paper and inspiration rays come in, you do it, first go, amazing. Is that how it works? Is inspiration something which you can one-shot it? You just have to take inspiration from the world, put it out onto the page, or in your case, into your P5 code, and you immediately get a great artwork. I think there's probably folks out there listening who are shaking their head. This is not how inspiration works. Inspiration is not a one-shot thing. You can't just expect a great idea to jump in front of you, and that your first attempt at realizing that great idea to be the best one. Everyone who has worked in fields where we're creating independent projects know that we need to practice, we need to develop our skills at developing ideas, not at just accepting the first idea that comes along and putting it on the page. So here's an example, a few pieces of artwork. This is Magritte's work, The Wonders of Nature, a very famous artwork with these two mer-persons hanging out on the beach. René Magritte was a member of the Surrealist movement in art, and one of Magritte's stylistic points was this kind of work with the fish and their legs. You can see these are supposed to be mer people, mermaid or mermen, I suppose, or mer-thems. But usually a mer person has a fish tail and a person head. So these ones are the other way around, right? We've got the fish head and person feet. So it's a surreal artwork. It's something which doesn't exist in the real world, and it's just kind of bends your mind in some way. That's how this field works. So did René Magritte just walk along the beach one day and think, wow, mer people, what a thing. What if I switched around the head and the tail and I made a fish person instead of a person fish people? What a great idea. And then went immediately back to his studio, drew this picture, and everything was fine. That is not how this happened. If we go to the next slide, I'll show you, go back to that one. If you search for Magritte's fish work, Magritte and fish, you come up with many artworks by Magritte and by others with this different, this concept of the fish and the person feet leading to one thing. So this wasn't an artwork which was just decided on in one go. It was a theme throughout Magritte's career, creating these mer-person works. And as like any good artist, René Magritte took a theme or a concept and iterated on that idea. So what is iteration? We've talked about iteration in the context of programming code, where you take one line and execute it multiple times. Within an artistic process or a development process or an engineering process, iteration is about building upon ideas through trial and error. So you start with one idea, you evaluate it somehow, critique it, and then do it again, but better, and try to build yourself up. And this process of iteration is, I think if you talk to a lot of artists, where the good ideas come from. Ideas maybe they're not things that just pop into your head and you develop great artworks. They're things that you develop for many years for professional artists in all kinds of art fields and designers. They're things that you develop throughout your career and you find the best way to express it, and they get better and better. So it's a very valuable process for anyone dealing with ideas, creating things from ideas. Here's another Magritte from 1948, 10 years before, or 5 years before the previous one. The same concept, but it's definitely a sketch in this instance. And there's an article linked here. I think there's a link. Oh yeah, very difficult to see that little link there. An article linked here about a discovered stash of papers from René Magritte, which were showing a process over time of sketching different works, looking at different ideas in different ways, and developing ways to create the final artworks, which is what we tend to see in a gallery or in a website or in a book. We see the final process, the final outcome of the process, not all the points in between. So here's just one example of a page with multiple ideas of this artwork that would include, it would be kind of a cartoon, including some text and an image, commenting on this surrealist concepts that he was exploring, the differences between objects, names, and images. So we've talked about iteration. Now we're going back to what inspiration is. Why is it that you don't see that artist being inspired, getting the, gamma ray hitting them in the head, having a spark of inspiration, feeling a good idea and immediately doing it. Most artists will tell you this: inspiration is for amateurs. Artists don't work with inspiration. They take ideas and nurture them over time. Let's go to the next slide. We have a quote here from an artist called Chuck Close. I don't know if you're aware of what Chuck Close's work is, but there's a very famous work at the National Gallery of Australia here in Canberra. This picture is called Bob. That's actually a painting, I think. Chuck Close works in a hyper-realistic style of creating an artwork which is almost photorealistic, and this is a massive artwork. It's very, very meaningful and impressive when you see it up close. That's just a background on what Chuck Close is, but the point is about Chuck Close's view of process. Inspiration is for amateurs. The rest of us just show up and get to work. If you wait around for the clouds to part and a bolt of lightning to strike you in the brain, you're not going to make an awful lot of work. All the best ideas come out of the process. They come out of the work itself. They come out of the process. They come out of the work itself. So, what is Chuck Close saying here? He's saying that professional artists make art, and amateurs don't make art, because the amateur will walk around all day waiting for the best idea to show up, and the professional artist takes the ideas that they have, makes them into art through work, looks at them, and then gets up tomorrow and makes some more. And if their ideas today aren't as good, then maybe the ones tomorrow will be better. And maybe they can take an idea from yesterday and improve on it today, and improve it again tomorrow. So inspiration is not something that artists are expected to work with. And in fact, inspiration is something that you find, you don't get. You have to find inspiration, because this process of work leads to that result. A few more slides, we can develop this idea a bit more. These are a list of rules by a famous art teacher called Sister Corinna Kent, who was in fact a nun, and was developed a very famous art program at Immaculate Heart College Art Department that was in the United States in the 60s. And Kent wrote down these list of rules. In this case, they're written down in a kind of artistic way, but let's talk about these. Rule 1, find a place you trust and then try trusting it for a while. Rule 2, general duties of a student, pull everything out of your teacher, pull everything out of your fellow students. Rule 3, general duties of a teacher, pull everything out of your students. Rule 4, consider everything an experiment. Consider everything an experiment. That's a good one for us, isn't it? Rule 5, be self-disciplined. That means finding something wise or smart and choosing to follow them. Being disciplined is to follow in a good way. To be self-disciplined is to follow in a better way. Rule 6, nothing is a mistake. There is no win, there is no fail, there is only make. There is only make. Rule 7, the only rule is work. If you work, it will lead to something. It's the people who do all of the work all the time who eventually catch on to things. Rule 8, don't try to create and analyze at the same time. They're different processes. Rule 9, be happy whenever you can manage it. Enjoy yourself. It's lighter than you think. Rule 10, we're breaking all of the rules, even our own rules. And how do we do that? By leaving plenty of room for X quantities. And that was a rule contributed by John Cage. So a few rules to point out here that are relevant for Comp 1720/6720. I think that these rules are relevant to everyone, no matter what identity you feel you belong to, whether you're more an artist than a coder, more a coder than an artist, somewhere in between. Because these rules apply to everything that students do when students are learning a discipline and crafting themselves as a person of knowledge, a person of skills, and a person of use in the world. So there is only make. That's part of rule 6. There is only make. And rule 7 is the only rule is work. So all I ask you to do in this class is to make art and do that better. And the more that you make art with code, the more that you code to make art, the better you will get at those two processes. That's why I have 3 assignments that are all about making art. Rule 4, consider everything an experiment. I think that if you want to be good, you want to get better grades, you want to have good outcomes, you should take risks each time with the sophistication of what you're going for as an artwork. So pushing that work a little bit further. If you're doing work that you're very comfortable with, you're unlikely to get better. You'll just stay within that little bubble. So by considering everything an experiment, you push yourself out of your own comfort zone and keep going. And if you can do that, you do great work. This is Sister Karina Kent's work. So I guess sometimes I receive feedback after folks get their marks. Maybe there are folks who are disappointed with their marks and they say, well, this was just the idea I had. It's unfair. Someone else had a better idea than me and they got a better grade. Well, that's because that's a misunderstanding of how ideas work. Ideas are something that are developed over time. And if you take the first idea and quickly make something as your assignment submission and submit it, then you might get very, very lucky and have somehow come up with something good, but more likely, the results aren't going to be all that great. There'll be an idea which has some fairly obvious flaws that the markers can point out, and the mark will be okay, but not amazing. If you want to do very well, then you come up with an idea, you experiment with it, take that idea for a walk, think about it. Next day you think, is that the best idea? So you've done your creative work, then you do your analysis of that idea, decide if it's good or not, and develop it, make something even better. And then if you do that a couple of times, you quickly come to an artwork which is really coherent, really flows, and the interaction makes sense. So developing inspiration has to be nurtured and iterated on. It doesn't just happen in one day. One more little quote. This is from John Cage. We talked about John Cage last week. It's a kind of out there quote. It may seem a bit useless here. So this is in one of John Cage's essays in a book called Silence. In Zen, they say, if something is boring after 2 minutes, try it for 4. If it's still boring, try it for 8, 16, 32, and so on. Eventually one discovers it's not boring at all, but very interesting. So this can mean a lot of things to a lot of people, but in this particular moment, I think that we can reflect on this quote as part of this idea of iteration over ideas. If you find an idea which is not working, it's boring on one day, try it the next day. If this idea is still boring, you keep working on it, try it the next day. And eventually, as you're working with this idea, you find what it is about that which is really interesting. And you can polish this idea to something which is appealing to you. And once you've done that, you might find that it's appealing to other people as well. So this is an interesting quote. It can mean a lot of things, but that's where I want to take it today. Process. Interesting comment from Avery there about The Little Mermaid by a reverse mermaid. Yeah, I wonder where are all the reverse mermaids in The Little Mermaid? They can run around, but they can't speak because they got fish heads. What's the right way to make art? What is the right way to make art? There's no right way, but there are common processes. So we're going to look at a few processes from different design fields, other creative fields. First, we'll just look at graphic design. What is graphic design? It's a creative field where designers develop graphic assets, images, websites, logos, colors for use within the commercial world. So here's an instance, a logo. You might know this is the logo from Airbnb. This is not something that someone just came up with one day. They walk in the office, they're like, there's your logo. Something very simple, but done. I'll have $100,000, please. No, developing graphic assets takes time and includes a lot of iteration. Here's an example. This is a sketch or a development sketch by a student who was working on an assignment about developing the logo for a hotel called The Loft. And you can see a lot of different themes being explored. Birds, the typeface, the font, some scene in the background, having a weapon, something which is more illustrative of actually a hotel room. There's a fish which is part of the font. So a lot of ideas being explored relating to this hotel, where it is in the world, in the city where it was based, and what these ideas could mean. So this is a kind of iteration on developing a logo with these different images. And of course, it's not quite finished yet, obviously. None of these look exactly like a logo. Probably if you were using this process to get to a finished logo, you go back to something simpler again after working in those different ideas. But you have to do that process of iteration. What about web design? Here's just an example of a web design kind of directory of different designs, and you can see this example of a website for a business that makes shirts. So they've got some elements here, a bit of text, a kind of logo made of text as well, menu down here, and then some representative images that give you a feeling about what it is these folks do. So how do people, excuse me, sorry about that, folks. I just swallowed something the wrong way. How do folks who are designing websites go from a blank piece of paper to that? One way that they often do it is through a process called wireframing. So they don't start in a code editor designing CSS styles. They start with a pen and paper, thinking about what a viewer will see when they see a website. So here's a few examples of wireframed websites. You can see this one on the left kind of has some text down here. It's got some text here. Maybe there's a few items in this page, and there's a kind of heading, and then a menu with little tabs indicators there. And this one starts with a big image, and then it has some text in different little blocks, and then the classic 3-block design. So a lot of these things they're not out of the ordinary for websites, but they have to be developed, and you have to figure out what you want. The reason that people do this is because often a designer isn't designing their own thing. They don't know what the best outcome will be because they're working for a client. And the client usually doesn't know what the best outcome will be. So they will come up with some ideas quickly using a wireframe. They'll sketch these ideas. They don't have to do any coding, just draw it up, present it to the client, and the client can then have a discussion with them about what they really want, what the best idea is, whether they might combine two ideas into the final product. So they'll do a bit of sketching work early in the process, working with the client, thinking about what the users will see to come to the best outcome. Sketching work early in the process. Think about that. What about in filmmaking? Do people just make a film by getting the camera, going onto the set, get the actors together and say, all right, let's just do this? That's obviously not how films work. Films are a massive process of design to work out how to frame each shot, how to make everything work together, what the actors are going to do, what they're going to look like, how the shots will work, because You can't just go onto set with the camera and decide, let's figure it out in the moment. What will happen then is that you will get nothing done, everyone will be frustrated, and you will waste all of your money and the film won't exist. So it needs to be super planned. Every filming session is super duper expensive. Everything is planned in a very detailed way. When you start with a film, you start with, even after the script is developed, after people have a screenplay for the film, they might have chosen who the actors are or what the characters will look like, and then they develop a storyboard for all of the shots. Here's an example storyboard from someone's cartoon. They've got a script, they know what the characters are going to look like, and they're working out every shot that's going to be in the cartoon so that they can then implement them. So this is now starting to look like what I'm asking you to do in your pre-lab next week. A storyboard should have a sequence of scenes that are occurring where you kind of have an idea of what should be there. What about an animation? Well, I've got one little video to show you. Something that happens in animation in between the final product, or drawing the final product and assembling that, and the storyboard. Sometimes people create a kind of animated storyboard called an animatic. So you can see this is Tangled from Disney. You can see there's the image on the right of what it looked like in the final film, and the animatic on the left, which is pretty good by itself, pretty expressive. All the storyboard images put together, and often when people are creating an animatic, they already have the soundtrack and the dialogue, so they can start to put those things together as well. Okay, that's enough of an animatic. So what do all these processes have in common? We've been talking about this all day now. I think you're starting to get the impression. They've got an idea of sketching things quickly, of being able to iterate on ideas, and developing inspiration, not just taking it and expecting to come up with the final product. In all of those creative industries, there was no way to come up with the final product at the first instance. You have to be very careful about sketching all of your ideas out and developing them and nurturing them and testing them. So now we come back to P5. The point of P5 and processing, which is where P5 came from, the point of P5 was to enable folks to sketch with code, both artists and coders. Here's a quote from Casey Reyes, who's one of the creators of processing. One idea was the synthesis of graphic design with computer science, combining the visual principles of design with ways of thinking about systems from computer science. We also wanted to share a way of working with code where things are figured out during the process of writing the software. We called this sketching with code. So there's an essay here that Casey has written. It's quite interesting to look at this. I'll just show it for a minute. Oops. This is a history of processing and where P5 fits into that. Processing came out of a group called the Visual Language Workshop at MIT Media Lab, who were working in the 90s about sketching with computer graphics. And what they noticed was that in their work, they were using a lot of quite heavy-duty programming languages, C++, and in the 90s, very expensive computers. But as the cost of the computers came down and the experience with these programming systems went up, or the abilities of programming systems, they were able to create a sketch pad for programming with a simplified language, which was still pretty powerful, and that was processing. So processing originally came with this little IDE, a little editor that you would use. There's examples of that later in the article. This is something where the inspiration from that was a previous system they had. Here's this sketchpad in processing. You would type your code in and get a little output. So we work a bit differently now in P5 because you get a more fun outcome when you can produce this thing as a website that everyone can then see. But this is still related. And of course, there's lots of outputs in P5. Here's all the things which came out of processing, including the Arduino system for hardware hacking. C++ and C had inputs into processing, and then that goes into P5, also taking inputs from JavaScript and HTML5. So processing and P5 are for sketching. That's what these systems are for, iterating on code quickly. So the idea of P5 was to enable this quick sketch idea. So you can do that design work, take the elements of computing that you need, put them together to create artworks over a process of iteration, instead of spending weeks and months polishing code to create an artwork which is not as good. It's better to be able to sketch quickly and then polish the code later. So you can rapidly try many things, different versions with code in P5. That is much more difficult to do if you're working in other graphics programming systems in C++. So here's some examples of different digital artists. Some we've looked at before in this course. Natalia Stuk, you can look at that person's Instagram there and see lots of different examples of work they've done with P5. Zach Lieberman, we've talked about Zach Lieberman before, working with computer vision, P5 and drawing, and Zach's Instagram is really interesting as well. I find this idea quite compelling, putting the nose and the mouth and eyes over the top of someone's image from a camera. Isn't that related to that original generative artwork we had of the distorted face being moved by mechanical actuators in space? Manolo Gamboa Naun, you can see their Instagram as well. Lots of really interesting images. This is quite psychedelic, isn't it? But a great idea of how to work with code and art. Helena Sarin. This is very expressionist kind of work, surrealist expressionism inputs there. Espen Kluger. This example shows a kind of combination of maybe quite raw computer graphics using these lines and applying that to a reproduction of a photo. Really cool idea. So we're coming now to the end point of this lecture where we bring these elements together. But if P5 is like sketching, why have I asked you to draw as well? Well, I haven't always asked you to draw. You can do this P5, the pre-lab submission can be drawn or it can be done in P5. If you want, it can be a good idea to think through your storyboard on paper and take a photo of that and include that as your pre-lab. I also think that it's useful practice to draw things in P5 if you want to. So one thing to point out is that this process is very connected with interaction. Even though you have a storyboard is just flat images, when you're making a storyboard here, this is not because your major project is supposed to be a story exactly. It's not saying that your major project should be like an animation or a film or like a website exactly. You're using a storyboard or a sequence of images that explain how you're interpreting your theme to illustrate the experience of a viewer. What will a viewer see when they see your artwork? Because an interactive relationship with an artwork is temporal. Someone comes up to the artwork, there's a scene they see initially, they do something, there's some kind of different elements appear or something changes about it, and maybe over time they have a feedback loop with that artwork and they get to a final state or something, some place of more development that deepens the understanding of the theme. So you could see a storyboard as the story of a viewer experiencing my artwork, seeing what the viewer sees and does. And in fact, we do this in computing and human-computer interaction as well. This process is called user experience design. So you're looking from the perspective of a user with a software product and illustrating what they're going to do, what they're going to see, what they'll be able to do next, what they'll find out, how they'll get information, what will happen. And you can trace through the story of a user, we call it a user story sometimes, through a product or a piece of software or a computer system, using it in a certain way to gain a certain outcome. And often UX designers use storyboards to illustrate the process of designing software. So we're really doing user experience design as well as doing all of the other kinds of artwork, inspiration, iteration that I've been talking about already. So computing and art here are not so far apart, actually. There is design in computing as well. So, one thing you could do with your storyboard is you could make some notes about what the user interactions will be. There could be more than one path through your experience when you're storyboarding your artwork. I would advise you not to get too complicated about your storyboard. A couple of different images, maybe 3 to 5 would probably be a good idea. Showing one path through the artwork, or maybe illustrating a multiple branches if you need to, but don't get over the top. I think reflecting on the feedback which I sent all of you on the Discourse forum, I wrote a post about what was happening in assignment 2, things I was seeing that were good, things that I was seeing that were not so good. My advice to everyone is to think about quality, not quantity. So don't think, oh, my major project has to have 100 different interactive elements. Think about it having a few interactive elements which are very deep and have deeply engage the user and deeply enhance their understanding of the theme. And that's where the real quality in an interactive artwork lies, in quality, not in quantity of interactive elements. Here's an example, a couple of examples of storyboards from the computing world. This story is about this guy here who's had an idea, writes a presentation, tests out the presentation with someone. That person doesn't understand it. They go back to the drawing board, look at their presentation again. Then when they're at the big board meeting, they give the presentation and everyone cheers. They're so happy because they've made their presentation so good. So it's a storyboard about how to create a good presentation through iteration. That's a bit circular, isn't it? Another example of something happening in an office. Someone does something on their screen. They go and get a bit of paper, walking by everyone else in the office, and they come back and put the paper in the bin. So I don't really know what the goal of this is, but it's an experience, a view of an experience that could be happening involving computers and people. I guess when you're doing your storyboard, it would be good to illustrate something that looks like what your artwork will look like, or a simple version of it. So if your artwork involves lots of characters, you should draw those characters in. I would recommend that you think about simple elements that you can use, not thinking about drawing 15 different people, because that's a lot of work. Making very simple figures, simple representations of what you want to express in your artwork. Drawing boards are not a test of your drawing skills. Storyboards are. They are just about this process of refining the sequence of events in your artwork. What will look like what, and what will happen when. A few more points. Keep it high level, keep it simple. This is a starting point. It doesn't have to be your final idea. I've been saying this all day. You don't come up with your final idea in one day. You write down the idea you have today, you talk about it with your tutor and your colleagues in next week's lab, and you start to develop your major project. You can read a few things here. I think now might be a good time to point out something we've got on the website called Artist Talks. At the bottom of the lecture page, after all my lectures, here's Artist Talks. So it's a collection of recorded talks about creative practice and process. I didn't make these, they were from a previous lecturer in this course, but he's interviewed 1, 2, 3, 4, 5, 6 artists from around ANU talking about what their process is for developing their works. There's something that might now resonate with you as you're thinking about your process for how you're going to approach the major project. So I just wanted to point them out now. They're really, really worthwhile things to have a look at. and reflect on how they could influence your process. And we're at the end of the lecture. So I'm going to do a little demo in a minute. Does anyone have a question? Just chuck it in the chat. Everyone's been very quiet today. I must have covered it all. You must understand everything perfectly. I'm not seeing any questions. That's okay. Someone's asking, how's your day been? Well, mine's been okay so far. I went for a walk with the baby. It's nice and bright. Came back here, thought about my lecture, started giving the lecture, remembered about daylight saving on the weekends. That's a bit of a brain explosion. I think there must be just me and one other person watching this right now. So I'll try to explain something which might be of use to folks. We're not doing a code example this week, or we're not doing coding topics in particular. So I thought I'd think about a little bit about a few tools that might be useful for you in doing your major project. So once you start to think about your storyboard, you might think, well, in my major project, I'd really like the user to see one particular scene at one point. And then I think it could then move to a different scene after some amount of time or after something has happened. So how are we going to accomplish that within P5? I haven't really talked about scenes. And I should point out here that having different scenes is not a requirement for your major project. I just know that a lot of folks will start to think about how to do that. Now, I'll point out that in week 10, in week 10's lab, there's a part of the lab called the project toolbox, and you might be interested to have a look at this now if you want to. But it's here it's on the task 3 recap, and you get a lot of revision information and some just practical advice for coding in your major project. Things about how to deal with fonts, how to deal with functions, how to deal with making buttons, how to do this bit, scene management, and how to do responsive design. That's pretty fun. So there's a few, this is really, this would be important information when you're starting to think about a bigger project, but it could be useful today. I'm just going to look at the scene management bit. So if you want to have multiple sections that replace each other, it might seem like this is challenging, but you can actually do this with what we've already got. And the trick is that in P5, it's very easy to make new functions. So we've got a function here called draw, but what if we had a function, someone says, that's cool, I'm using an array of page functions and index to draw to the current page. Well, that's exactly the kind of thing I was planning to do. That's a great comment. I guess in the simplest instance, if I wanted to have two scenes, I could say draw scene 1 over here. Oh, someone's been using a click counter for this. That's not a bad idea either. I mean, there's no one way to do it. And I guess what I'm going to tell you is probably not even a particularly smart way to do it. It's just an easy way to do it. I want to have two scenes. The first scene is going to be making some, I'm going to pretend each one of these is a draw loop. Pretend this is a draw loop. So the first one's going to make a background, we'll make it white. And the second one's going to make the background gray. And this one's going to make an ellipse, which is going to move around the screen, following the mouse. This is the world's worst artwork. Sorry about that, folks. If you want to see good artworks, don't watch my channel. Well, width 50? No. Width times going to be 10% of the width of the window, and it's going to be 10% of the height of the window. Excuse me. Window width. Make this the full width and height. And then this one I'm going to make a rect. I should make a fill color as well. Fill. What color am I going to make it? You know, 120, 120, 0. That'll do. This one's going to also have no stroke. And I'm going to have fill 0, 85, 85. Really boring colors. And it's going to be a rectangle which isn't related to the mouse. It's also going to be width times 0.15. Heights. Points 2. A little bit higher than it is wide. And what are we going to have for X and Y? I want this to be based on time. I'll use one of my tricks from last time, that sine is going to be heights frame counts. Whoops. I should have started with some example code. I'm just making it, I want it to move slowly back and forth across the screen. Same count times 0.05. Divided by, that would be easier, wouldn't it? Divided by 400 or something. That's going to be from -1 to +1. Plus, store the page index after refresh. Refresh will always restore everything. I think refresh will always restore everything, unless you somehow storing to some persistent information in the browser. I would assume that users are not going to press refresh. That was a good question there by Ali. So the question is there some way to, when the user refreshes the page, store some information and get that back later? There are ways to do this in JavaScript. I don't know what they are. You can figure it out. They're not something which we cover in this course. So within this course, assume that people are not going to press refresh during their experience of your artwork. Just assume that's not an option. Times width divided by 2. I'm going to actually put some, that's going to take it off the left-hand side of the page, plus width divided by 2. Okay, so far so good. Now I've got my worst artwork ever. Let's draw scene 1 and see how it works. So I'm using, in my draw function, doesn't actually have much code in it now. I'm just referring to this other draw function. That one's got my, oh, there's my lovely blurgy green circle. Gene's got a great idea. Yeah, local storage by a JSON string. That's probably something I'll talk about in a later lecture if I can think about how to do it. It's a really clever idea. Load it from the start of the file, but it's certainly advanced information. And now I'm going to draw scene 2. So the questions going on in the chat right now is like, how can you store information in the user's browser? It's not something we cover in this course, but we might be able to add it as an extra bit of information for your toolbox. Here's my scene 2. I want it to be a bit faster. Is it going to come back? I've done this wrong. Julian, help me. I know Julian's in the chat. Whoops, there it comes back. Hooray! So I've got my moving square. That's fun. And I've got my ellipse. So if I draw these both at the same time, I will just get the moving square because it's going to run this first function, and then over the top of that run this function. So this one has a background, it draws that scene, and then over the top of it, it wipes the background and does that second one. So we can't just use them both at the same time. Let's do it so it's time-based. If frame count greater than 200, we'll put draw scene 1 there. I will do this less than, else draw scene 2. So now we're going to do a time-based method of getting these to be drawn one by one. Now we've got my first scene and then my second scene. Try that again. You'll see it. You have to blink even you'll miss it. You see these ellipses moving around, and then I've got my scene 2. And it will only be drawing one of these scenes at a time. So you can see I'm either doing scene 1 or scene 2. I could layer the scenes on top, but then I might be asking the draw loop to do too much work, and that might slow down my frame rate. So I think there's some way to do this without frame count, just using time. Someone help me out here. I've got the reference. I've just forgot how to do it. Time, delta time, what's that? That helps you find out your frame rate. That's handy. Frame count. That's handy. Do I know how to do frame count? I guess you can do frame count divided by frame rate and then find this in seconds. Frame rate. So let time so far equal frame counts divided by frame rate. This assumes that the frame rate is always the same, which is probably not a very good assumption. Time so far less than 3 seconds. That's going to be less than 3 seconds. And if not, it will be the next scene. Whoops. Oh, maybe what's my frame rate measured in? Ah, what? Frame rate is a function, not a variable. Come on. Come on, Charles. First big mistake. Treating functions as variables. I should have known from the color. It doesn't seem to like doing that. Ooh, that doesn't seem like, or maybe it's the prints which was messing that one up. Oh, whoa, that's not good. Changing scene really started to mess it up. So this probably isn't a good way to do it. What is frame rate? $60-ish. I'll just assume it's 60 and never changes. Okay, that works better. That frame rate, because it changes over time, it goes a little bit up, a little bit down. It's not a good idea to use that in every single draw loop to measure time. that was messing up my measurement. So this is one way to do it. Someone else is saying, oh, we can use millis. I forgot about millis. I should have known. And millis was, I always used to use that in processing. So millis is a way of getting time so far equals millis divided by 1,000. Millis is a way of getting the amount of time since the sketch has started. It's also a function. That comes in milliseconds, so if you want that to be in seconds, you just divide that by 1,000. I'll comment that one. We're getting better and better at this. And there we go, straight into millis. Nice, 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 nice. Thanks, folks. Great help from the chat here about how to do this. Now I had another sort of plan to use a kind of counter in some sense to help with this. So I might have a function here, let scene counter equal 1. And then I'm just going to have if scene counter is 1, draw scene 1, else if scene counter equals 2, draw scene 2, else if scene counter equals 3, we'll do another function, draw scene 3, make another one down here, function draw scene 3, and this one's just going to be like, I don't know, a blank scene. We'll just have a different kind of background. Very simple. Oops, that's not how you spell function. Very simple scene there. So now, we're going to, I'll take out that let time so far. Initialize that up here. I might make another function after this, which is going to check scene or update scene counter. And that's part of the draw loop function, update scene counter. Okay, and now we can have another little decision about what number we need our scene to be. If time so far less than 3, it should be scene 1. Else, if time so far greater than or equal to 3, we'll change it to scene counter equals 2. Else, if time so far greater than or equals 3 and click count greater than 0, scene counter equals 3. So I think someone in the chat was saying they were counting clicks. That's a good way to do it. Function, mouse pressed, click counts, plus plus. Maybe I'll reset the click count to 0. I haven't made that a variable yet. Let click count equals 0. Okay, so what am I planning to do here? Every time I click the mouse, I want to update click count, add 1 to that, to see if I've clicked in a scene. Maybe I'll make that 5. That'll be a bit better. Scene 1 happens if I'm less than 3 seconds. If I'm more than 3 seconds into watching the sketch, I should go into scene 2. And then as soon as scene 2 starts, the click count resets to 0. So, I might put that, the click counts setting to 0 within each scene. That's probably a better way to do it, isn't it? So now, well, that's not going to help because it'll reset it each time. Oh no! Oh no! Click count greater than 5. How am I going to make it just update the click count within that first scene? I'll think of that in a minute. I'm not going to use click count until I get to scene 3. So I'll set click count equals 0 in scene 2. Okay, so I wait 3 seconds. We should get to scene 2. No, that's not going to work. Because I need to count the clicks in scene 2. I'll have to put the click count equals 0 in scene 1. So scene 1 I can click as much as I want, and my click counts are not being counted. Now I'm in scene 2. Time is greater than 3. 1, 2, 3, 4, 5, 6. No, it's not working. Someone will have to figure out a better way for me to do this. And click count greater than 5. It should be greater than 5. Print click count. This is our click count. Click count. Good way to find out what a variable is. I'm sure I've done something wrong here. Oh. The problem is it always goes into this one. We're never moving forward because it satisfies this. I need to make this and click count less than 5. So now it will move forward into the next bit once the click count is greater than 5. If it always gets stuck in this part of the if and else part, even me, I can get stuck on my if then else's. Here we go. So the click count's always getting reset. Now we're in scene 2. 1, 2, 3, 4. Aha. And we've got a red screen into scene 3. Okay, so a few funny ways of checking where you are with scenes. This is not intended to be, you know, the end of how to do this. The final way. If you want to do something more complicated, you probably need to think of more complicated ways of doing it. You'll need to discuss that. It's the kind of thing which we could come up with some really great forum discussions. Yeah, thanks for that advice to use mouse click instead. That could work too. I think I got it in the end. The other thing which you could consider within this little demo is how you might make buttons. So there's a demo here about how to draw a button that will return whether the button has been pressed or not. That's a handy way to do things. So you can make buttons that are draw themselves and return whether they've been pressed in the same line of code. If you're used to doing UI design in different languages, this might look a little bit crazy, but it will work within P5. I might try that out on another day. So I think that's enough demo for today. I'm going to add this to my week 8 simple scenes. Add that to my collections. Add to collection 2021 sketches. Cool. So if you ever want to check out the different collections which I use in lectures, you can see there's a link on the lecture page to all of these different ideas I've tried out. Lots of ones last week to do with music, and hopefully this gives you some inspiration going forward into your assignments 3 and major project. So at this point, I think I'll say thanks, folks. I will see you on Thursday for the second part of this. We're going to talk a bit more about trajectories through an experience, hooks and trajectories. So I will see you folks then. Have a great day.